Hello today. How are you everybody? So today we are going to look at how to generate land use land cover for the Landsat 8 with complex engine. All the time it has been difficult, it is always difficult to have land use land cover done manually using your either GIS or QGIS. With the right coding and scripting with JavaScript and GAE, we'll be able to do that in real time. So let's look at this. Code is ready. It's ready to make. Okay. Now, where we're looking at is initially we said 2014 land use land cover. We are going to generate 4 classes. Now, the first thing is we are going to import our AOI, that's area of interest. Now, here we have this is the link to the area of interest in Lagos State. We have the data set already here. Is it? LG, that's Lagos State. So we import it into the interface of the scripting as define your area of interest. This is our AOI. Is it? Then we want to see that this Landsat 8, we know that some have clouds. Most of these Landsat 8 have clouds, most especially in Africa where they don't have good, they are not planned for when they are capturing this data set. So they try to remove the cloud. In our previous videos have shown how we can remove clouds, with Landsat 8, with Google Earth engine, restricting the Google Earth engine. I showed a satellite imagery with clouds, and I added the scripts for it, and I removed the clouds as well when Landsat 8. So these are scripts, all this is a script for removing the mask when on Landsat imagery. Now we assume that this Landsat imagery has cloud, so we want to mask it by removing the clouds, so we mask the clouds area to form almost zero cloud imagery. So this is the Landsat that we collected as Landsat 8 collection 2 for 2014. So this is the VR of the Landsat. I showed in previous previous videos on how to bring in your data into your scripting interface. So after bringing in our data, there's Landsat 8 CO2 tier 1 L2. So we are going to look at, we extract it. Now we fill that data as the filter date. Then we open the filter date from 1/1/2014 to 31/12/2015. So the interface of that, the range of time we are looking at to get our Landsat imagery. We said we have we ask Google Earth engine to give us filter this date. This is a function of filter date. To filter date, or that means to select imagery between 1st of January 2014 and 31st of December 2014. Then here we want to filter our AOI. So we want to filter just our area of interest. We are not interested in all the swath of the Landsat imagery. We are only interested in our area of interest, which we have here, LGA, and we said is our AOI. So our area of interest. Then we now apply this mask to it so that we remove the cloud. We repeat that, let it remove the cloud, from this imagery that's our area of interest. Now we want to now run the composite of the year. VR composite Landsat 8 dot clip AOI. So what we say is this Landsat 8, that we have selected our AOI, just say filter our AOI, and we have masked it, that we have removed the cloud, and I'll say clip it as Landsat 8 median. We have just get the median data between 21st January 2014 and 31st December 2014. We are asking it to get a median data, and we said clip our AOI. That means get the median Landsat imagery between these two dates, then clip this median imagery to our area of interest. Now we want to do band classification. So we say VR bands. What band do we have? We have band 2, band 3, band 4, band 5, band 6, and band 7. So we have done, we say band 7, then we now say define land cover classes. So how many classes do we want? We want the water body, we want the urban center, we want the vegetation, and we want the grey soil. So training data, so we want to use training data with actual geographic coordinate example points. So we are using points. So these are the points. This is what we use. This is the point. If you want to train your data with rectangle, or by drawing a polygon, or by regular rectangle, or by your points. But we are using points, some example points. We draw points on our what's called on our mapping interface to represent our training samples. So we have water. Now we got 2 training samples for water. That's this longitude and latitude, and this longitude and latitude. These are points dropped on water bodies. Then we have urban centers. We have two points that we draw on for urban centers. That's 1 and 2. Then we have vegetation, 2 points also for vegetation, and we have bare soil, 2 points also. Now say merge all classes. So we want to merge all the classes. So with this, it's created classes, land use classes. Now we now say merge all classes. That's the script for merging classes is VR triangle training data. That's all this training data. That means we're saying merge all water bodies, merge vegetation soil vegetation data, merge these bare soil and all other classes. So we say merge urban, merge vegetation, merge bare soil, merge, this one is water, merge. So after merging all classes, we now say sample the composite to get training data. So how do we sample the composite to get training data? Now say VR training equals composite.select all the bands dot regions. That's LA regions. Collection is what your training data. Here you have defined your training data from the major classes. Your training data is all this. You are merging all the classes, which is equal to your training data. Now here you are saying select the composite to get training data. Here we have composite.bands.LA regions, and you put this sign, then you come down. Collection is what? What's your collection? That's your training data. That's this. Properties is land cover. Scale, because we are using Landsat imagery, scale is 30. Now we come to training a classifier, e.g. random forest. We are using random forest to classify our land use land cover. Now we are saying VR classify. This is the function. e.classifier.small random forest. We say create 100 training samples. A 100 classifier, sorry. Train 100 class random classifier train. That's training sample. Now, if your training samples is too much, maybe you say create 1,000 training samples, the data will be too big for Google Earth Engine to process, so it may slow down or it may not work. So I think 100 training samples is good. So features equals training, class property, land cover, input properties, bands. Now you go to classify the composite. Now this function is VR classified equals to composite dot select what? The band. That's input properties. Select the band, input properties dot classifier dot classify. So which is your classifier, and this function is your classified function. Then here you define the visualization prism, how you want to visualize it from minimum, that's minimum and maximum. Minimum is 0, maximum is 3, and the palette, your blue, red, green, yellow. Adjust color as needed. You can change your color as you like, but for me, I use color palette of blue, red, green, yellow. Then add LULC layer to the map. Now we want to visualize our LULC. If you don't put this script, this one, we will not. We want it to centralize. We said map the center object. So center the object to our AOI. That's it. Map center object. That means center the interface of GG to our AOI. That's our area of interest, which is defined as map.center object open bracket AOI at what ratio? At 10. Here you can change it. You can put it 8. You can put it 6. You can put it 20. Just the way you like. But for me, I put 10. Here we have map.map layer, add map layer. Here we want to show our map on the GE interface. If you don't put this script, this function, we won't see the results. We won't see the results of our analysis. So here we have to add the layer that we're working on. So we said map.add layer, put in bracket. What layer are you looking at? Classified. Here, remember we said classified equals composite dot select bands. So we are adding this to the layer. This function, we are adding it to the layer here. Map.add layer classified. Then after adding this, we now say vparam. So follow this color palette, blue, red, green, yellow here. Then name it LULC classification 2014. Here is the export function. If you want to export it into your Google Drive, so you can download it and then run the final map into QGIS software or ArcGIS software. It depends on what you want. So export classified image to Google Drive. There's a function. Export.google.to to drive. Open this bracket. Image is what? It's classified. Here. This classified. You remember up here we define what classified is. This is the definition of classified. So we come back. Image. What image do you want to export? Classified. Description. Land use land cover 2024. We want 4 classes. Name and prefix. Put anything you like. Scale is 30. region of interest, that's our AOI. Because 30 is because we are using Landsat imagery, so the scale is 30. Then we run. Let's run and see. So you see, brings us to our interface. So we have our land use land cover for Lagos State, clearly done. We know this is our lagoon. This is our lagoon, so it's correct. Somewhere around there is what's it called? Oshodi airports in the Ikeja or something. It's somewhere around there. Here is around the Ikeja, Oshodi, and the rest. See, it's a mixture of urban and bare land. So, which is great. Here are more of agricultural vegetation zones. You know, if you run more classes, if you try to run more classes, you can have different classes of vegetation here, but we just want it on 4 classes, so we have this. So when you finish, you come to the task. You see the task highlighting. You click it, and you say land use land cover classification. This is it. Then you run. You click run. When you run, click run. And when you click run, it brings you here. It says land use land cover 2024 classes. The coordinate system is using scale 30. Folder where you want it to go into, Earth engine export, file name, this is the file name, and the format that you want it is GOT. You can say chief recorded in no, I want GOT. Then you click run. Then once you click run, it will run maybe depends on the speed of the computer, maybe 3, 4, 5, 6 minutes, and it will be able to check your TIFF file in your Google Drive. Then you can download it, take it to our GIS, which is then you'll be able to see the classification. Then you just do the classification directly, which has been done already. You see the 4 classes. Just you can convert polygon. Can convert raster to vector. Then run your land use land cover smoothly like that. So thank you for this for today. So next time we will be coming up with other form of analysis.